Section 8.5, I don't really have very much to say here. It's another modelling section, and with modelling, again, as you know, it's questions in context, and the exam board like us to see questions in context, and so they provide us with extra exercises just with questions in context, but because they're questions in context, I usually can't tell you anything or warn you of any particular kind of question. The only thing to point out here, though, is the link with mechanics. So if you look at the projectile motion part of the second year mechanics, which I think is, I don't know, about chapter 9, something like that. Now, if you look at that, what we get is we get x and y, where x is the horizontal distance and y is the vertical distance of something, and we consider those two things separately. Both of those things we can write in terms of t, and in fact, example 12 is exactly a projectile motion question. That idea of having x as the horizontal distance, y as the vertical distance, and t as the time is an idea that we can use, and they've done it in example 11, they've done it in example 12. So there's an example from mechanics, another application of how parametric equations can be used, where we need three different variables, t for time, and then x and y for the horizontal and vertical distances. So if we use those three things to integrate like that, then we can answer this. Now this question here could be almost exactly out of the mechanics chapter if you read through that one. So have a look at that kind of thing. And eventually there will be a video on this channel covering that as well if you're not happy with it. Here we go with the plane's position at time t after takeoff can be modelled with the following. So here we've got x in terms of t, and we've got y in terms of t. Now we've also got v's and thetas involved, but v is the speed of the plane and theta is the angular elevation of its path. So assuming that it's kind of taking off and heading off in a straight line, theta should be a constant, and v is going to be something that we're asked to find later on as well, I think. Oh no, perhaps not. So, but theta is a constant, so we can be asked to find that one. Oh, here we go. Look, the plane speed is 50, so we're assuming that our v is constant as well. Now, again, it's modelling. If it's taking off, then it's not going to have a constant speed, and it's probably going to take off in a curved sort of way. Planes don't sort of go horizontal and then suddenly take off at that angle, do they? They kind of curve the way upwards. But it's close enough for the model so that we can make it into a question and ask maths questions of A-level students about it, okay? But again, the idea is think about the context, think about the what we know about parametric equations, and then we can solve it. Now, I'm not going through these examples particularly because these examples are only going to teach us about these examples. The way to be able to do these kinds of questions is to understand everything to do with parametrics from the whole chapter, and then just use sort of mathematical common sense and a bit of cunning and a lot of practice, and you'll get there in the end. So I don't think going through those particular examples is going to solve anything really. It's just, as we say with all these modelling sections, apply everything we know in context. So there we go, chapter 8 all done, and differentiation awaits in the next set of videos.